My name is Rusty Belcher. I work with Imaginate Technologies in Virginia Beach. I actually live in Hampton, Virginia. We're an Autodesk reseller, a partner, support. I work a lot with shipbuilders. Shipbuilders are in the shipbuilding area in Virginia area. I work with a lot of shipbuilders. Those are my primary customers. But I've been working with the AutoCAD toolset, Inventor toolset, with Imaginate for the last 13 years. So I've worked with a lot of customers around Virginia and on the East Coast. And we're here today to focus on, I always call it AutoDesk's best kept secret. And that is AutoCAD Mechanical, and specifically the top 10 tools that I use inside of AutoCAD Mechanical. How many of you have seen those beer commercials for the most interesting man in the world? You guys know that phrase. If you're not familiar with it, this old guy comes on, the most interesting man in the world, and he says, "I don't drink beer often, but when I do, it's Dos Equis," which is the brand of beer. And I will tell you right now, I usually work with Inventor and 3D modeling, but I've been teaching AutoCAD for the past 13 years, once a month. Love AutoCAD. I would not be standing here today if it wasn't for this application. But I don't get to use AutoCAD as much as I used to. But I have to tell you, when I do use AutoCAD, I use AutoCAD Mechanical. There are so many things inside of this tool that make it an amazing tool for mechanical and manufacturing design. And it really is. When you compare it to just regular AutoCAD, it's like comparing a Cadillac to a Volkswagen bus. It really is amazing. And one of the things I deal with customers all the time, and they'll tell me what they want to do, and sometimes they tell me they've spent extra money on certain pieces of software to do certain things. And I mention, well, you have AutoCAD Mechanical, and it does that for you automatically. And they look back at me, and I didn't know that AutoCAD Mechanical could do these things. So hopefully today, I'm going to share with you my top 10 productivity tools, or the top 10 reasons I choose AutoCAD Mechanical when I do my AutoCAD work. This is an AU class, and it has to be formatted a certain way, so I've got the class summary up on the screen, and I think I've really given you the class summary already. These are my reasons for choosing AutoCAD Mechanical. But there are some class objectives we're going to cover today. You can familiarize yourself with that. But basically, I'm here to discuss these 10 reasons. And honestly, I don't want to spend a lot of time in PowerPoint. We've got a lot of ground to cover today in the application. So I hope to spend as much time as I can in the application today. I asked earlier, how many of you are currently using AutoCAD Mechanical? And I actually got quite a number of hands that went up in the air. So we're going to take a look at the top 10 productivity tools for AutoCAD Mechanical today. And the first one, before I start this off, this is not like the David Letterman top 10, okay? I'm not building up to my favorite one, although I did put my favorite one at the end. So there's no importance to these numbers. They are just my reasons why I use AutoCAD Mechanical. And I have to tell you, I wish I could have done 20 reasons or 30 reasons. It's almost like an insult to just do 10. It was kind of hard to limit it to just 10. But the first thing I want to focus on today is the mechanically enhanced commands that are available inside of AutoCAD Mechanical. Now I'm just going to start a regular drawing today. And for time's sake, you guys were here together for an hour. So I got 60 minutes to cover 10 topics. So somebody can do the math in your head, how much time I have for each topic. So instead of drawing everything piece by piece, I'm going to use my tool palettes today. I want you to understand that everything I drag off the tool palette is just regular CAD geometry. There is no mechanical applications running in the background. This is all just regular CAD stuff. If you see me use the tool palette, it's just CAD geometry. So the first thing I'm going to bring in is a little piece of plate here with some holes drilled in it. And I have that set to explode, and it's just to get started. In the PowerPoint, I mentioned a few of the things that have been enhanced inside of AutoCAD. Center lines, rectangles, hatches, and the list goes on. You guys ever wonder, with AutoCAD being, what, 30 plus years old, right? You know there's somebody at Autodesk every year that has to dream up a new feature for the next release of AutoCAD. You know how hard that would be? After 30 years, what's left to put into the application? And quite often, I laugh when I see the new releases of AutoCAD because the things that they're adding to it now, we've actually had inside of AutoCAD Mechanical for years. And it's really kind of funny. Hey, I see annotation scaling. That was awesome when you could declare your annotation scale for model space and everything updated correctly. We've had that in Mechanical for 15 plus years. It's just amazing to see these tools come out. So I've always got the feeling that somebody's like handpicking the Mechanical features, and every year we lose one over to AutoCAD. But some of these tools are just amazing. I wanted to start with center lines. I just have a center line command. I can just come in and easily add my center lines. The offshoots are automatically added for me. So all of that's being calculated. And it's not just a line that's on the center line layer. There's a lot of options for center lines. So if I want to put center marks in all of my circles, one click and it's done, and I'm on to the next annotation task. Let's take a look at the rectangle command. What is there to do with rectangles? I mean, they just enhanced rectangles in AutoCAD, the regular AutoCAD, a while ago. But inside of Mechanical, there's over 20 ways to develop rectangles, including half-widths. I work with shipbuilders a lot, and a lot of times they deal in half-widths. I don't want to draw something for the entire boat. I just want to measure it for the half I'm working on. So all of those options are developed here. You can also draw squares with the rectangle command. How many times have you needed a square and you need to use the rectangle command for it, and you end up putting the same number in twice and it feels like it's an extra step? So I'm going to grab one of the unique ways to do a rectangle from the center out. And I love that, so I'm just going to tab over here with the dimensions and drop that extra rectangle on there. Now, I've been using AutoCAD for quite a while. I started when I was 18 years old. I started working at Newport News Shipbuilding. I was a steel fitter. And I served my apprenticeship there, and I got into the engineering group. And I was actually one of the first groups to go through AutoCAD training over 20 some odd years ago. So I remember distinctly working with construction lines. I don't know how many of you use construction lines anymore, but I use them all the time. Even today, it was how I was taught, back on a pencil and paper. And the construction line tools inside of here are amazing. You can just immediately pick all the geometry, send the construction lines anywhere you want, and then we can start using some of these neat little rectangle tools to start developing our side views. So I'm just going to track down, we'll tab over and do, it's a 1-inch piece of plate, and let's draw another rectangle here, piece of plate that's on top of that. I'll track down. So I've got my two pieces of plate here. I want to project my lines. This is a neat little tool here for CAD or construction projection. So I can come over to the right, put my projection line in, and then I can use my construction lines again, the automatic construction lines. This time I just want to send them right, and they bounce off the projection line up here, and I can easily go and do my side views. And I think it's important that we remember how we were taught to draft back in drafting class. All of that is built right in, pardon me, to AutoCAD Mechanical. The next thing I want to focus on is line types. I remember early on customizing my AutoCAD so I can have different commands that drew different line types. AutoCAD Mechanical has had that forever. There's a line palette here for contour lines, hidden lines, text, dimension lines, center lines. All of this is configurable. So I'm going to start the hidden line command, and anything I draw will now automatically go onto the hidden line layer. So I'm just going to draw a few hidden lines. I'll show you these lines here in a minute. But I've just taken advantage of my construction lines here to make this an easy process. Then I can go back to my palette, put myself back on the contour layer, and handle the lines. This is going to be a section view when I get finished. Very nice. And when I'm finished with my construction lines, pardon me, a single click is going to remove them. And again, back over to the mechanically enhanced idea here, it's not just the center line, it's all the possibilities of the center line. For instance, the bisector. I want to come in and bisect these lines and drop a center line right between the two. And if you think about it, there's nothing to snap here. So I have a way to drop these center lines in very easily. And it's all based on mechanical standards. You're going to see that a little bit later in another topic. What about the hatch command? What can you do to advance the hatch command? You can have preset mechanical hatches ready to go at a moment's notice. So if I want a hatch, I just come in. I've got it already set up for the mechanical settings. And I can come in and add my hatches for my section view extremely easily. The fillet commands and the chamfer commands have also been enhanced. Now, it's still the fillet command we all know and love, but there's a setup option that allows you to preset fillet sizes. So if your company has standard dimensions that they need to work to, you can set up your fillet command to only work with those particular values. You can also have it dimension while you're working. So, for instance, if I come up here with a fillet, it works just like your normal fillet command, but if you repeat it, there's an option to add the dimension. And then you can come in and immediately go right into the radial dimension and start adding the information you need as far as the dimension. And the chamfer command is exactly the same way. If I go to the setup option, you have options for your typical chamfer lengths. And if I chamfer a part, it will dimension it automatically. And those are the things that make my life easier as a mechanical designer. So I'm just going to undo those. We don't need those for the entire project. And guys, I'm just scratching the surface as far as all the mechanically enhanced commands that are possible inside of AutoCAD Mechanical. I asked some of the people that came in early, what's your favorite AutoCAD Mechanical feature? I mentioned I love the whole chart command. I also like symmetrical lines. And this is just a line command. I mean, what can you do with the line command that hasn't been done already? Well, how about building in mirror automatically, so whatever you draw on one side automatically updates on the other side? Excellent commands. A really nice way to draw shafted parts and things like that. So let's take a look at my next feature I want to focus on. And this is called Associative Hide. Some of you might have been using AutoCAD Mechanical long enough that this used to be called 2D Hide, and then it was called Associative Hide, and now it's called Hide Situation. But it's the idea that you can have 2D objects sitting on top of each other, and the nature of the orientation will automatically generate your hidden lines for you. I like this feature so much, I talk about it like this. This one feature is worth the price of admission. This one thing will get me to convert from just regular AutoCAD to AutoCAD Mechanical. So I've got a design that I'm going to start working on here. It's just a block. So I've got what I'm going to call mount A, and then I've got another mount that bolts to that one. And let me rotate this around 90 degrees. We'll track over. We'll put that there. So these two blocks, I'm going to consider these two mounts on top of the original mount. And if you stop, these are blocks. So what would I have to do in order to generate my hidden lines? I'd have to explode the block and break the block and change the layer settings and all of that. Well, with AutoCAD Mechanical, we have the Hide Situation command. We simply pick the objects that are on top, and it generates my hidden lines automatically. It's a nice little dialogue that helps you keep track of what's on top of what. And for this demonstration, don't get too mad at me. I'm going to run an LT scale just to change my line types. I'm going to talk about annotation scaling a little bit later, so just for right now. I also wanted to mention this is an associative command. These parts ever change, the hidden line situation will update automatically. So for instance, I love working with blocks, so I'm going to edit my block, and I'm going to add a new circle. And I'm just going to make this circle to where it interferes with that hidden line. So when I finish my update, you'll notice that the hidden line now becomes visible. It actually sees that inner circle as a hole. It's automatically built in and ready to go. I mentioned that I work with shipbuilders a lot, and this is a shipbuilding example that kind of highlights the Associative Hide command. So what I have here, the yellow here, it represents two pieces of plate that are on top of some green stiffeners or T-bars. So I'm going to set up the hide situation. This is just a rectangle. I've got a line here, I've got some arcs and some lines. This represents the butt joint. And this little hole, this is a hole in the deck. So I'm finished, and I can easily generate all my hidden lines really with one single command. And it's important to remember that it's an associative command. If I move the hole, the hidden line situation is going to know to update automatically. The amount of time it takes to edit mechanical data is much less than the amount of time it takes to edit conventional AutoCAD data. So really, again, there's no question for me when I start AutoCAD which version I want to start with. Let's take a look at our next feature, mechanical content. So AutoCAD Mechanical comes with a vast library of mechanical content. Nuts, bolts, bearings, washers, all the mechanical content you could just about dream of has been drawn already and ready for you to place into your drawings. There are really two kinds of content. You have feature content and you have part content. So let's talk about feature content first. I've got my brace here. I'm going to go in and edit this one. And I'm going to add a hole. Notice I said add a hole. I'm not going to draw a circle. All right? Drawing a circle, that's what when I'm working in an AutoCAD class, that's what I would say. But in a manufacturing application like mechanical, I want to specify I'm going to drill a hole. It's different. One is a mechanically flavored command. The other is just a piece of geometry. So I'm going to go over here to the Content tab. This is where all the content's accessed. So you have libraries of contents. One of the most important features here is the ability to develop your own content. There's no way Autodesk is going to come up with an all-encompassing content library, but you have a great tool here to develop your own. But you have screw connections and fasteners, nuts, bolts, bearings, washers, hole features. So if you want to drill anything, you've got all your holes here. Your shaft generation tool. If you ever have to do gears, your shaft generator is where you're going to do your gear work. All of your steel shapes are here, as well as plenty of other commands. So I want to drill a hole, and this is going to be a free hole. So I'll pick the top view, and then it's likely going to prompt me to select the correct size. All of that is based upon the international drawing standards that we all know and love. All of that information has been placed into the tool automatically. So I don't have to stop and look up the actual hole diameter every time I draw a circle. I just pick the whole feature and drop it in place, and all that information is done for me. I'm going to save my changes to the block and then move on. The next piece of, or the next content I want to focus on is actual part content. So I've got a swing arm that we're going to use here. Swing arm is going to sit on top of this part, and I'm going to rotate it around, something like that right there. There's going to be some sprockets over here and a chain, and there's a spring here that adds tension to the idler or to the sprocket arm here. And I've got to bolt these things together, so I'm going to grab, or I'm going to start developing a bolt detail. So real quickly, let me hatch my bolt detail here. And I want to add the fastener connection that's going to hold all this together. So let's go ahead back into content, and let's do a screw connection. And it's like going to the hardware store. I can come in and easily pick all the fasteners. I'm going to keep this as simple as I can today for time's sake. So I'm going to come in and grab a hex bolt UNC front view. We're going to add a washer at the top. Our first hole will be through free fit. Our second hole is going to be through free fit. We'll add another washer on the other side. and we'll finish up with a nut. And I need you to be careful here, make sure I get the right one. Hex nut UNC. All my sizes available are listed automatically, and all I have to do is pick each spot where the holes begin and end. We'll finish that up, and it draws all this information for me. There's a couple of different washers available, narrows and options there, so it draws all of the data for me automatically. It runs the 2D hide, hides all the objects in the background so that my CAD data looks correct. One of the things I love with content is, it's a tool here called Power View. All of the content is drawn with a front view, a side view, and a top view. So if you ever need an alternate view of an object, it's extremely easy. Come in and pick your content, select the view that you want, and then you can go drop that off somewhere else. So I got that bolt that goes right there, automatically runs the hide situation and fills it up correctly for me. So let's do some sprockets. I will tell you right now, this is not something I would typically, well, you could do sprockets very easily with Inventor. How many of you use Inventor? How many Inventor users here? Love Inventor, and I primarily work with Inventor. But I'm going to give you guys some hints here and about Inventor versus mechanical. When it comes to things like sprockets and gears, Inventor does what's called a simplified representation. Mechanical does a detailed representation. So if you look up specifically on gears, if you look at an Inventor gear and you put the same gear inside of AutoCAD Mechanical, Mechanical's going to give you the detailed version. That's the one you want to go into production with. The Inventor gear is simplified to keep the face count down so you get a more reliable, dependable model. So your real 2D gear is actually the better one. And the same thing goes with sprockets. So let's draw a couple of sprockets. Let's go to the chain area. We'll just draw a sprocket. I'll specify my center point. I'll pick the chain I want to use. I pick the number of teeth. So for this example, 15 teeth with a 1-inch hole through the middle of the sprocket. And it draws all of that immediately for me. And let's do another sprocket. This one goes down here, and it has 12 teeth. Real quick, easy to add that content. Now, I want to build the chain. I love Inventor, but how many of you know that Inventor does not model chain links? Inventor models a path for the chain to follow. It doesn't model a detailed chain link. If you want that, you can always hop into Mechanical and generate it as a detail and include it in your Inventor drawings. So before I do my chain, I'm going to do a length calculation. This tells me how long the chain is. So you just basically pick these tangent lines, the little outer diameter circle of the sprocket, and hit enter, and it tells me on the command line that 34 links are in that chain with the selected chain that I used. So now I can come up and actually draw the chain. Again, something Inventor doesn't do, a detailed chain. So we can come in, we select the path where we want the link to start. 34 links. We'll finish this off, and it draws it all for me. Now the tool is actually smart enough to show you the gap. This is an idler, so it wouldn't fit perfectly. But when I did the length calculation, there was an option that it would have adjusted the swing arm and the sprocket until it fit perfectly. There's a lot of options here we don't have time to dig into. But how about some other content that we typically don't do? How about springs? You got to love drawing springs. It's amazing. I'm going to do an extension spring here. These are all based on a spec, a catalog of real springs. You could go down to the hardware store or go to your supplier and get these parts. And I want this spring, we'll go here from this point to that point. A lot of ways to choose springs. You have the power, the load the spring gives. You have the length of the spring. You have the wire diameter. All of that is an option up here for you to check. But I'm going to do a simple load and length analysis. And I'm going to pick this, the largest spring I can use. And I want you to notice down here for later in our demo or for later in the class, I have 122 foot-pounds is the maximum amount of force this spring applies. Nice to know that. Now, I can select Finish. I can draw the spring at any extended length or contracted length or at any point in between. And it draws it in there, does the hide situation for me all automatically. It's a great way to work. Just being able to drop content in, have the content do the hides automatically so my details look nice and crisp. And I don't have to do all of that classic CAD work when I'm working with content. All right, let's talk about dimensions. You gotta love annotations and dimensions. And AutoCAD Mechanical has some amazing dimension tools. We call them power dimensions inside of Mechanical. So I kind of consider myself old school. I don't necessarily like that term anymore because my beard's getting white and people just call me old now. But when I learned AutoCAD, when I was in production with AutoCAD, we did all of our work in model space. Y'all can gasp in shock. We never used paper space back 20 years ago when I was actually working in AutoCAD. So AutoCAD Mechanical actually loves model space. It actually, one of the core features here is the ability to just work in model space if that's what you want. So I'm going to grab a part detail sheet here. This is all just regular CAD data. And I'm going to do some dimension work. And I mentioned annotation scaling. Look, when annotation scaling came out for AutoCAD, I thought it was amazing. And then I remembered back in Mechanical, in Mechanical we call it scale view. If you love annotation scaling and you try to do that in Mechanical, it's going to say no. Because Mechanical has a classic way to do this. So basically, I draw a rectangle. And anything inside of this rectangle, I can declare what the annotation scale would be. So think about it. In my model space, I can have as many scales as I want. I'm not limited to a single scale. So for annotation scales, I'm going to use half scale just to get my dimensions to show up correctly on the screen. So let's bring in my part here. Now this is the same part. I'm going to drop it onto the sheet. But does everybody understand what the tool palette's doing now? It's now bringing up the local copy, so I've got my hole that wasn't there before. It's a great way to work and keep your parts organized. So I want to talk about dimensions. So let's go over here and we'll start the dimension command. And we're going to do power dimensions. I teach AutoCAD all the time. And I love AutoCAD. But one of the things that drives me crazy is all the different dimension commands. You want a linear dimension, you want a radial dimension, you want a diameter dimension. What kind of dimension do you want? That's the command you have to start. Well, with Mechanical, I have one command that does all of that. I have one command that does linear, and then a whole supporting option here for setting up a mechanical dimension. So I can easily come in and change my numbers of decimal places. And then with the same command active, I can lock my dimensions in at the correct distance and start stacking them up one at a time. Excellent. Again, using the same command, if I pick an arc, I get a radial dimension. And I'll just repeat the command. If I pick a circle, I get a diameter dimension. This makes dimensioning so much nicer, so I can focus on the dimensions in their format, and I don't have to stop and go in and start new commands every single time. We also have what I've always called automatic dimensioning, baseline dimensions, chain dimensions, ordinate dimensions. It just goes on and on. So let's do some parallel baseline dimensions. Love working with blocks, so I just pick the block, pick my start point, and it's going to dimension everything automatically. Remember I told you they enhanced a lot of commands with Mechanical? They actually enhanced the erase command. And what the heck can you do to enhance the erase command? Well, it's called power erase, and if you select mechanical content, you'll see that the parts update automatically, or the mechanical content updates automatically. So my baseline dimensions update, and I can come in and change my, oops, let me undo that. I can come in and change my decimal options very easily. What about the leader command? What can you do to enhance the leader command? Well, with the leader command, if you select feature content, or regular content, the name of the content's automatically going to be added to the leader command. So it's like whatever, it's like a note that's automatically going to give you the name of the content that you used. Excellent way to annotate your designs. I don't know how many of you guys use ordinate dimensions, but I've done that in the past, and I definitely want to include that here. Let me just change my CAD geometry just for a second. I want to put some center lines on all my holes here. And I'll finish up modifying the block that way. So I got all my center lines in place. Now for my automatic dimensioning, I can come up and use ordinate. Just select the block, select your origin point. You can drop all your dimensions off at one time. One of the reasons we use AutoCAD Mechanical today is to annotate our design work. You might do the design work in Inventor. You might do the design work in regular AutoCAD. But one of the things that people use Mechanical for is its annotation set of tools, because they're just so much nicer than the conventional AutoCAD set. What about detail views and section views? These are things that you classically avoid with AutoCAD because you're talking about multiple scales in the same space, and believe me, I've taught AutoCAD enough to know how difficult that can be. Very easy inside of Mechanical. We'll go back over here. There's a whole detail view command. I can zoom in, specify my detail view, set up my new scale. Remember the scale area I mentioned before inside of Mechanical? I can have multiple scaled areas. All of that works here so that I can, even on the same sheet, have different scales going on at the same time. All of the mechanical content and a lot of the mechanical features are all standards based. So if you double click the detail view, the standard for the detail view is going to show up. And there's so many different things I can do. I can do a jagged edge for the cutout, or I can do a smooth edge, or I can do a full circle with two circles and a line that crosses between the two. And that's what I want to do, so I'm just going to drop in the line there. And I think, besides that it's just easy to draw it, the amazing thing is when I go back to dimension it. So I've got one-to-one going on over here, so I'm going to start my dimension command. Just select an arc and we'll get the radial value. Do another one just to test it. With the same command over here at a different scale, I'm going to get the same value. And I don't have to worry about all of the CAD work that's necessary that supports all that in the background. I can just focus on designing and not being the CAD tech that has to know everything about what dim scale and all the dimension options that are available inside of AutoCAD. It just works, and works very nicely. Another thing I love is the mechanical symbols. I can't tell you how many times I've gone on site and seen an AutoCAD user or a company invest a lot of money in creating their own symbol library or their own custom routine to do welding symbols or surface texture symbols. Again, you have this conversation, well, AutoCAD Mechanical does that automatically. Oh, it does? Yeah, it's done it forever. So I love the mechanical symbols. I'm going to come in here, and again, I'm just going to drop another part detail sheet here. Again, that is just regular CAD geometry. I'm going to do my little scale area trick again. And we'll set this up for half scale. Again, the symbols that I'm going to use are they are sensitive to the annotation scale on the sheet now. So let me delete that one. So let's add some dimensions. I mentioned I'm going to start with symbols here, but I want to talk about dimensions just for a second. So let's do a dimension from here to here. We'll drop it off, change my note there, and I want to specify that this is an exact dimension. These are critical dimensions, so I can easily come in like inspection dimensions, things like that, and add that information to the dimension. I have a dimension up here for the diameter of the hole, and I want to add a tolerance to that dimension. That's a lot of fun inside of AutoCAD. I love AutoCAD, but let's face it, there's a lot of ways to do dimensions and tolerances, and all of the methods are not available inside of regular AutoCAD. How many of you, honest to goodness, how many of you have exploded a dimension just to get the tolerance to look right? It drives me crazy. I used to do that all the time. So we don't want to do that. What we want to do is come up and turn on the tolerance and then choose the type of tolerance we want to use. So I can easily come in with my upper, lower values, just hit enter and populate that in there. Now, I want to set up some datums. So let's go back over here to the Annotate tab. The Annotate tab has all the annotation tools on it, and all of the symbols are over here as well. As a matter of fact, on the Home tab, you have a symbol flyout if you want to use that. So let's grab some datums. Let's specify I've got datum A over here. So A is automatic. Let's put datum B down here. And we'll put datum C over here. Excellent. So now I can do my feature control frame up here. You don't have to attach it to anything. And you can specify the position and your tolerance, and your maximum situation against datums A, B, and C. All of the symbols that come with mechanical are all based inside of some dialog box. And if you find yourself using the same symbols over and over again, like we all do, you can start your own symbol library. So when you build these things once, you can just put them in your library and they're there the next time you start the application. Excellent. Let's talk about weld symbols. I'm not going to weld these pieces together, but there's a weld symbol tool, and again, it's all based inside of a dialog. I can come in and mark off anything I want, the size of the information, any note that I want. I can add it to a library of common symbols if I need to. Everything's ready to go when I need it. Surface texture. I'll mention surface texture. It kind of depends on where you come from in the world as to how you use surface texture. So a lot of these commands work in a very general way. So for instance, whether you were taught to put the surface texture in or on the line, it doesn't matter. It works both ways. You can specify your finish, click OK. And it also incorporates all of the advanced surface texture symbol capabilities. It's all built in, ready to go. Back over in PowerPoint for a second, you see all the advanced surface textures that we can add. If you want to do leaders with any of these symbols, you can, all built in automatically. And again, this is another feature in my top 10 list where I'm just scratching the surface. There's actually plenty more to talk about. Bill of materials and balloons is another reason I use mechanical. How many of you love counting your parts at the end of the design? Getting your part count down so that your purchasing can get the stuff ordered so that we can go to manufacturing. I have been on site, no lie, and the guy that counts the parts, you can tell because he's got little red marks on his computer screen where he takes a pencil and goes, counts all the parts and writes them down. Last week I was working with a Navy contractor. We were talking about counting parts, and they say, well, here's how we do it. The last time we did this job, it took 100 parts. This time, we'll order 120. That'll give us some fluff just to make sure we got enough to do it this time. In today's world, we can't afford to just order 20 extra fasteners because you know you're going to lose one, or you don't want to spend time and get the part count done. Your CAD software should tell you exactly how many parts you have in the particular design. And AutoCAD Mechanical can absolutely do that. On the layout panel, the annotate panel, you have your bill of material tools. So what's nice is, while I was using the mechanical content, the bill of material was automatically developing the fasteners and the sprockets and the chains. All of that's automatically in my bill of material. If I want to add a parts list, it's a single click. I can come in and add a parts list to the drawing. We'll zoom in and see all the annotations or all the information about the particular content that I used. And it's very easy to edit the actual parts list. Well, that's great. But what about the blocks that I was using up here earlier? It didn't count those. I don't see a mount 1 or mount A and mount B. So how do I go about counting blocks? I love using the bill of material tool with just regular AutoCAD blocks. This is really nice. So I can come in, activate my block. This is one way to do it. And they have a tool here called a part reference. This is another of those commands, worth the price of admission, to add this to my block. All I do is drop a blue dot on my block. That blue dot doesn't print, and I can actually give this thing a name, tell it what material I want. All of the metadata here, you can control what it asks you every time you drop a part reference in. We'll finish up our changes, and let's do one more. Let's modify this mount here. The mounts, because I'm using the 2D hide, there's actually double blocks here. There's the original block, and now the block that's automatically been populated with the hidden lines. So that's the one I'm going to work on. I'll drop the blue dot. This is mount B. My advanced naming scheme here. Click OK, and we'll finish up that change. So just by adding those two blue dots, those parts now show up in my bill of material. Now if I want this one, I could come up, drop the blue dot on that one. I could copy this blue dot, put it on this one. Part count starts to work and update correctly. But I love this. What happens if I bring in other parts? Now that I've got the blue dot on the block, my part count's going to update automatically. So I can incorporate some mechanical functionality with my regular AutoCAD blocks. Just amazing how nice it is to now start counting the parts correctly. If I had my block library set up with the part reference already, all of this is automatic. I don't have to stop and add the part ref. It's already there. So let's talk about balloons real quick. We can absolutely come in. The balloon commands, we mentioned them, I think, a little bit before the class, how easy it is to come in and have the balloons automatically line up with your parts list. I'll just do, it's called an auto balloon. We'll come in and add those there. You can do your balloons vertically if you want to. But the bill of materials and the parts list, the balloons, all of that is amazing. Here's a workflow I love with the balloons and particularly the bill of material. Inside of Mechanical, I can export my bill of material to a spreadsheet. If you're an Inventor user, there's nothing major about that. Almost all of our bill of material tools export to some spreadsheet format. But with Mechanical, I can modify the spreadsheet data, maybe attach it to an ERP system, and then I can import the data back into Mechanical, filling out my parts list, which is something we can't do inside of Inventor. So this export, the bill of material, in Mechanical, it exports and it imports back into Mechanical. That would be a great feature for Inventor to adopt, to be able to export the BOM, hook it up to some purchasing system, get the necessary information, and put it back into the CAD system. That'd be great. But we've been able to do that inside of Mechanical for years. Drawing standards. Real quick on this one, I'm not going to go in depth with this, but your drawing standard is embedded in your CAD file. All your drawing standards, you can go in and check it, and you can use it, you can establish your drawing standards. As a company, we all should have standards and we should abide by them. But working with customers throughout the years, I know how difficult that is to enforce. With AutoCAD Mechanical, it's very easy. Inside of Mechanical, if you go to your options or your preferences, you're going to see a couple of extra tabs in your drawing. You can come into the AM Standards tab, and here is your entire CAD standard. And the way they organize this is extremely nice. There's dialog boxes for every notation you see here. The actual standard itself controls things like text color. Not like the text styles that we work with AutoCAD, but this is my CAD standard text color. And if I want to change it, I can easily come in and maybe I want orange text. And I can see the orange text appear. That's what's controlling the parts list and some of the dimensions as well. But I can come in, I can control my dimension styles, I can control my hole charts, all the hatches I talked about earlier, the thread lines, the center lines, the detail views. You can preset how each of those works automatically so that each time you come in, you don't have to worry about setting it up, you just use it. Oftentimes when I'm working with a customer and we want to document their CAD standard, when we get finished setting up mechanical, we simply go into every one of those nodes and do a screenshot, put that over in Word, and when we're finished, we have like a 20-page CAD standard for the company, or at least the beginning of it. So it's an excellent way for you to enforce your CAD standards. All right, number 9, mechanical calculations. I was at a client site last week, and they were talking about how much money they had spent to do, they bought some software to do beam calculations. The same software also does screw calculations. Talking to them, I mentioned, well, you guys have had Product Design Suite for years. Why aren't you using AutoCAD Mechanical to do that? No lie, the guy looks at me and goes, I didn't know Mechanical could do calculations like that. Absolutely it can. And I hate to hear where people have spent extra money to do what their tools already do. So we're going to do a couple of the I'm going to do a calculation with the FEA. That's just the nice colorful one. But there are real handy calculations here. Shaft calculations, beam deflections, screw calculations, moments of inertia. All of this is built into the tool for you to use anytime you need it. So when I talk about FEA and mechanical, I've got to say this. It is a first run at FEA. It is not equivalent to some of the Sim 360 tools that you see in the cloud now. The calculations those tools do on 3D parts are amazing. We are limited here to just the profile of the shape. And if you've studied FEA, you know that that's really what FEA is. It's just a bunch of 2D profiles stacked on top of each other. So I'm going to bring in my swing arm. I'm going to drop this off. And let's run a calculation on it. I'm going to go over here to Content. We'll run the FEA. We'll pick inside of the profile. It runs the mesh for you automatically. And I'm really interested in this design right through here. That's where I anticipate the main forces to build up. So you can refine your mesh. Nice little option there. So let's go ahead and add our supports. You can add a sliding support inside a hole. You just pick the same spot twice and pick inside the hole. You get your sliding supports. Got my supports there. And then let's add the force. Now, when it comes down to the force, remember the spring that I was using earlier? Had 122 foot-pounds of force max on that. So I know where this number comes from. I'm not just guessing here. So I'm going to put in here 300 foot-pounds. Twice what that thing should ever. We do have to specify the thickness of the part. And you do have to specify the material settings. But you can plug in any of the material settings you need. I'm going to do a von Mises stress analysis, but we could do safety factor analysis, tons of different types of stress analysis and deformation analysis if we wanted. I'll go ahead and drop my chart off to the side, and I can actually see here that the main stress blister happened here on the fillet. I would have thought it would have happened up here in the sharp corner. Typically, we don't include sharp corners in our parts. It's a bad design. But the stress is actually down here. But I can go over and see what my maximum yield point is, 27,000, and right now our max is 13. So I'm good. At twice the amount of force this will ever encounter, we're good. And at least we've taken a good first look at our design. And we're pretty much assured that this should work in production. Wish I had time to go through all the other calculations that are available. This, again, is where one of these features, the calculation features, worth the price of admission to get into mechanical because they're so nice to have. And I will say this, I'm going to finish up with this drawing here. All of the drawings that I've done here can go over to the Inventor drawing very easily. Has anybody done that? where you can copy all of this. You go over to an Inventor drawing, you do a draft view on the drawing, set the scale, copy paste all of this right into your Inventor drawings for your details. So the last topic I'm going to focus on, one of my favorites, and is actually documenting Inventor data with AutoCAD Mechanical. So many of us have invested such a great amount of time in our AutoCAD standard. I just can't stop and start using IDW or the Inventor's version of the DWG. I have a lot of customers have other tools running in AutoCAD they need to use on their drawings each time. Well, they can still model inside of Inventor, but drop all the drawings and the annotations inside of AutoCAD Mechanical. So there are actually currently 3 ways to do this with Mechanical. You know, Mechanical, you can just open up an Inventor DWG, start adding annotations. That's always worked. That's great. But the other 2 ways I do want to show you. So the first way, I'm just going to start a new file based on my part template. This is really, honestly, this is an AutoCAD feature. It is just also included now inside of Mechanical. So if I go to my paper space option here, go to my Layout tab, I have Base View, Projected View, Section View, things like that. So when I start my base view, notice I can pull in AutoCAD models as well as Inventor models. So I'm going to grab my Inventor part. We'll just drop the view off. It automatically does all of your orthographic projection, and it drops your lines in quickly and easily. That's amazing. Now, I actually don't want some of these views, so I'm going to delete them. And it's just regular CAD data. There's nothing special about it. But I do want to show you the projected view. Let's do a section view. I'm going to section view here, right through the center of the part. We'll drop off our section view. And then I'm also going to do another projected view of the isometric view. So it does all the hatching for me. This is, honestly, this is more of an AutoCAD command. If you really dig into this, you'll see that it has its own layer scheme. Doesn't use the mechanical layer scheme that's part of the tool. So for instance, with my hidden lines, if I want to set the color for that in the line type, I can. Or for the hatching, I can come in and set that information very quickly. And I could get my drawings to look extremely, get the general CAD work done extremely quickly. These are associative. If the Inventor model ever changes, you're going to get a warning so that you can update this inside of AutoCAD Mechanical. But there are some really nice benefits here. Remember the leader? I showed you this earlier. If I come in and pick a feature, the information for that feature is automatically going to transfer from Inventor over here to AutoCAD Mechanical. So it's like having an awesome whole note inside of the Mechanical tool as well. Excellent way for you to work. Let me show you another way. In my opinion, it's the preferred way. It's called an Inventor link. I've had this in Mechanical for a long time. So I'm going to come up here to New, and actually you start this file with a specific command. It's called a New Inventor link. You pick your template, and then it immediately prompts you to select an Inventor file, parts or assemblies, doesn't matter. Both processes I'm sharing with you do parts and assemblies. So I'm just going to do an assembly this time. And this is the model of that sprocket chain assembly I showed you earlier. I'm just going to look at this from the top view. And I want to put this on my sheet of paper. So when you start this command, when you right-click, you get the view commands right away. And they appear in model space. So I can come in and do a new view. It's going to be the base view. Let me set my drawing scale here. And let's do 0.25. We'll pick OK. I'm going to use my UCS to orient the view, and I'm just going to drop it up here in the corner. It's going to calculate all my hidden lines for me, all automatically. I mentioned, I think I asked this question earlier to some of the people. Does anyone here remember Mechanical Desktop? That's the tool I first started using when I was back at the shipyard 20 some odd years ago. And the tools here are actually the old Mechanical Desktop tools for generating drawing views. It's just doing it from an Inventor model. If I right-click, I can do another new view. This time I want to do an isometric view. We'll Pick OK. You just simply select the view you want, generate the view here. It automatically draws all the data for me. I can move a view, get it aligned on the sheet of paper, and I'm ready to go. Now here's one of the big benefits for doing it with the Inventor link. You can go over here to your bill of material. Your bill of material tool automatically hooks into the Inventor bill of material. So you can access all the BOM data from Inventor, generate your parts list, and we can start going and doing our balloons. So just like we did before, we can do the auto all. Let's do a vertical line of balloons here. Or if you just like dropping the balloons one at a time, you can come in very much like Inventor and dropping all of the balloons, placing them wherever you want them. So there you go. So you can absolutely include AutoCAD Mechanical in your Inventor documentation processes. All of those annotation tools I showed you make annotating your Inventor models a breeze, but we're still using our classic AutoCAD application. Listen, I know in the digital prototyping world today, it's all about 3D. And there's no doubt about it. Inventor and Fusion, I'm a big Factory Design Suite guy. I love Factory Design Suite. All of those 3D tools are getting all the press. And I mentioned I started off with our presentation today. I think AutoCAD Mechanical is pretty much one of the best kept secrets at Autodesk. How functional and how awesome it is to have that tool as your CAD tool of choice. So I hope you guys see as we finish up the presentation really what I was going for. 10 of my favorite reasons for using AutoCAD Mechanical. And again, if I have to use AutoCAD or if I'm using AutoCAD, that's the application that I'm going to choose to use. I think we're right about on time. I got about 4 minutes left. If anybody has any questions, I'd be glad, for the next 4 minutes or so, to answer any questions you have. Before I answer the questions, if you can, I know that AU app is a little slow today, but if you can, please go online and fill out the survey for this class. Even if you do it tonight sometime, hopefully the app will catch up when we all, chill out and having some dinner tonight. Take the time and fill out the survey for the app for the class. Let me know what you think about the class, and I'll be glad to hopefully improve it or change it next year if we need to. So I appreciate your time and attention. I hope all of you have a fantastic time at the rest of AU. And again, if anybody has any questions, I'll be glad to answer them for you. Yep.
Sometimes I like just to use mechanical to pull things into AutoCAD drawings because I like starting in AutoCAD and then doing mechanical. Why is it that you have to explode them? Is there any way you can actually deal with those parts in AutoCAD?
So sometimes AutoCAD Mechanical will add some unique functionality to the geometry. It is a tool that the geometry is custom to the application in some cases. How many of you use AutoCAD Electrical or have looked at AutoCAD Electrical? One of its big features when it was introduced was it's just AutoCAD data. There's nothing special about it. Well, AutoCAD Mechanical is not like that. Some of the things are unique to Mechanical. And when those things end up in AutoCAD, quite often you'll get a warning that says, hey, this was generated in another version of AutoCAD. I'll just show you the proxy graphics, things like that. So that's typically what you're looking at. So it is possible that you can explode it, degrade it, get it over to just plain AutoCAD if you want to. Any other questions? I'm going to be up here for a few minutes packing up, getting ready to go some classes on my own. So if you come up with a question, I'll be up here for a few more minutes and be glad to answer that for you. So I appreciate your time and attendance today, and you guys enjoy the rest of Autodesk University. Thanks, guys.